Welcome back to this online virtual class. Once again, in this video, I am going to solve another problem in the topic of formation of PDEs by eliminating the arbitrary constants. Okay, let us see this example number 2. Z is equal to x squared plus L into y squared plus m. X squared plus L into y squared plus m. So can you guess how many arbitrary constants are there and what are they? X and y? No. X and y are independent variables. Apart from that, the left hand side, z. Z is a constant? No. Z is a dependent variable. X and y are independent variables, right? So apart from these three, we have L and M. L and M. So these two are the arbitrary constants. Our aim is to eliminate the arbitrary constants L and M. So how many constants? 2 in number, right? How many independent variables are there? That's also 2, that is x and y. So once in the given relation, the number of arbitrary constants as well as the number of independent variables are in equal number. So while eliminating the arbitrary constants, which will give exactly the first order partial differential equations, right? So that is the clear idea. So let us see how to eliminate these arbitrary constants, namely L and M. So the obvious and the simple method is try to differentiate one term with respect to x and y to z. Okay, so let us differentiate the equation number 1 z with respect to x and y. What will happen? Let us see that. Now differentiate 1 partially with respect to x and y. X and y. So we differentiate only z with respect to the independent variables x and y, not with respect to the constants. Because already we know what is the differentiation of a constant? 0, obviously. So we don't try in that way. We can differentiate only with respect to variables x and y. Now when I differentiate this with respect to x and y, what is the left hand side? Z. So what about dou z by dou x is equal to, let us say that right hand side of equation number 1, x squared plus L into y squared plus m. Correct? So when I differentiate with respect to x squared becomes 2x. Right? What about L? L is a constant, becomes 0 by using the linear property in differentiation. Is correct? Then is in the product form. So what about y squared plus m? This as it is case. So we can retain this term y squared plus m. When we differentiate with respect to x, only x term can be differentiated. Other than the x terms, everything is constant. So it is a product form, so we retain that. Now from this, what we get? The left hand side is dou z by dou x. What is the notation for dou z by dou x? P is equal to 2x into y squared plus m. So by that way, what about y squared plus m is equal to p by 2x, right? P by 2x. So from the first time differentiating with respect to x, I am getting y squared plus m value is p by 2x. So what about with respect to y? What about with respect to y? Let us see that. The same equation number 1 with respect to y. So the left hand side is dou z by dou y. Z with respect to y. Clear? The right hand side x squared plus L. So there is no y. Usually we assume that this is a constant. So it is 0 if it is the linear expression. But here it's a product form. So here x squared plus L is retained because in the product form we retain this term x squared plus L, and y squared plus m. Once we differentiate y squared plus m with respect to y, we get is 2y. We get this 2y, is right? Because with respect to y this time, the term x is treated as constant. Now what about the left hand side of this one? Dou z by dou y is nothing but q, isn't it? This is the notation for the dou z by dou y, q. So by that way, it is the right hand side is 2y into x squared plus L. So from this, I found that x squared plus L is q by 2y. Is it clear? Isn't it? So I found the values of y square plus m and x square plus l. Right? Now using x square plus l value, or you can name it as equation number 2, this is equation number 3. Using equations 2 and 3 in the given relation number 1, we get z is equal to, what about x square plus l ma? X square plus l is q by m, that is q by 2y. What about the y square plus m value from the equation number 2? It is p by 2x. So let us simplify this. The denominator side, it is 2y into 2x. What is 2y into 2x? That is 4xy. Let us cross multiply it to the right hand side, from right hand side to left hand side, then which gives it is 4xyz is equal to p into q. So there are no arbitrary constants like L and M. It is only in terms of x, y, z and p and q. What about p and q? They are known as first order partial derivatives. So this is the required partial differential equation of order 1. That's it. This is the idea. So right? This is the partial differential equation of first order. Got it?